Okay, so this section in part is on inverses, and we've talked about inverses in the past. So basically an inverse is when you're switching the input and the output. Okay, and we'll show you more about that. We know we have to have a one-to-one function in order to have an inverse. Now this is going to be a big part of what we do in this section. When we can take the inverse of a function, we say it's an invertible function. Now most of our polynomial functions, they can't be inverted. They're not invertible. But some of the basic ones we can find the inverse for. And so that's what we're going to work on in this section. Now, you also might remember the steps for finding an inverse. There were 4 steps. Switch the x and y. Oh, first you write f of x as y, write y. Then switch the x and y. Solve for y. And then finally we use that inverse notation. So you replace y with, and it's f inverse of x. So remember, that's not a negative exponent, it's the inverse notation. Inverse notation. Okay, and we'll go over these things as we go through this section. But I want to talk about this problem. They have it in the book, and I thought it was a good one to look at. I'm going to make it a little bit bigger. Okay. So I thought it was a pretty interesting problem. It's this trough that collects water. And what they want to know is they want to know the surface area of the water. So pretend like, here's the water line. We're trying to figure out then what that surface area is, depending on how deep the water is. Okay? So they give us this diagram. Well, what we're going to look at first, we're going to look at that parabola shape. Okay, and they tell us in the book it's a parabola. All right, so let's have a little piece of graph paper here, and we'll draw this parabola out. Oops. Well, try to draw the parabola. Okay, actually I don't need arrows on this because that parabola doesn't go forever. Oops, there the whole parabola went. Okay, so there's a distance up here at the top that we actually know. So we're going to put that parabola right on with the vertex right at the origin there, okay? What we don't know is the height, but we know something about parabolas. We can figure out, some type of equation. This is a basic parabola with a vertex at the origin, so we know it's in the form y equals some constant x squared, right? Okay, so that's the basic equation for a parabola. I didn't use f of x, but I could have. We don't know what a is, but we can figure that out. We know this point right here, okay? We know this distance right here, okay? So the distance, let's see, across the top here is 12 inches, okay? So this is 6 inches right there. And we know this point has, like if the whole trough was filled up, that would be a depth of 18 inches, okay? And so that ordered pair right there is 18 comma 6. Oops. Okay, so this point, I'll put it in a different color here. This point right here is 6, I was right the first time, 6 comma 18. So you got to think in terms of x and y, right? Okay, so we're going over 6 and up 18. Okay, Now we can plug those numbers in to find a. So we're going to do that. So we're going to have 18 equals a, and x was 6 squared. So that's 18 equals 36a, or a equals 18 over 36, which is 1/2. Okay, so we know a is 1/2. Now we know this equation for the parabola. We know that this right here is based on y equals 1/2 x squared. Okay, but what tells us what? How do we know what the depth is and what the distance is here, right? Okay, so they're going to give us the depth. They're not going to give us the x value. Okay, so we're not going to find points all along this parabola. We could make a table of values to do that, but what we're going to know is the depth. We're going to be able to measure the depth of the water. Okay, so y is representing the depth of the water, and that's the piece we're going to know. So what we want to do is we want to find the inverse here. So I'm going to go ahead and multiply by 2, take the square root of both sides, and I'm going to get x equals plus or minus the square root of 2y. Okay? Now, that is going to be an interesting thing then. So we've written it in terms of the depth. So now if you tell me the depth, I can tell you the x. Okay? And we're going to need that piece of information. Okay. I'm going to restrict this because when I did this part over here, like up here, I'm only looking at the right side of the trough, like there's a parabola, and I'm only really looking at this side right here. I'm not going to think about over on the negative side, and the reason for that is because I'm not going to have a negative distance, okay? So we can say x, we can restrict x to say x has to be greater than 0, okay? Well, when we do that and we, solved for y, we're going to say that if we're going to say if x has to be greater than 0, then it's not going to be the negative case. So we're going to say x is equal to the square root of 2y. Now that only gives us this side of the parabola, okay? This side. And we'll talk about what we're going to do. So I'm going to go to the diagram that they gave us and look at that. Remember, we are trying to find the surface area of this water that collected in the trough. That is a rectangle. Okay, so we're trying to find the area of a rectangle. All right, so keep that in mind. So what do you need for a rectangle? Area of a rectangle, length times width, right? Okay, so the length, we know how long it is. It's 3 feet long. They tell us that. Okay, so length, that's taken care of. That's the L. But it's the width that we're working on here. So this width right here, it's only half of the width, but that is x. That's the x that we just came up with. Whoops, right there. But we're going to have to double it because we have another piece over here, right? So I need 2 times that. So I need the area to be length, which is 3 feet, times, and then I'm going to need 2 times the square root of 2y. All right. Does everybody know why that 2 is in there? I'll go over that again. So your formula right here is telling you x. It's only telling you this part of x. So this part. So there's another matching one because it's symmetric. There's another piece on the other side. So you have 2 of them. You have another x there. Okay, to get that total width of the rectangle. Okay, so then we're going to multiply this out. Okay, so I made a little mistake. So let's fix that. Let me scroll this up a little bit. It's a unit thing. So remember up here when we had, I just didn't check carefully, it was 3 feet. Well, we're doing this in inches, right? This is inches here and inches here. We should have done that way at the beginning with the diagram. We should have made that 36 inches. Okay, so now maybe I can just squeeze a 6 in there. 36 inches for that length. Okay, and then that's going to give us the area equals, and then we simplify this to be 72 times the square root of 2y. So then if we know the depth of the water, we can figure out the surface area. So maybe, you know, we have cows that are going to come drink out of this trough, and we have so many cows, and we want to know if there's enough room for all of them to drink the water if it's at a certain depth. Okay, and then this represents a function in terms of y where you can find the surface area of that water based on the depth. Okay, so kind of a long example, but I wanted to go over it because I thought it was a good example to show you some things you might have to do in the future, you know, designing and drawing diagrams and pulling out that parabola and looking at it, things like that. Okay. And when I say in the future, I kind of mean like next semester. Okay, so I don't know that we're going to get into the physics and stuff in here so much, but just, you know, a little example, a little bit of heads up of how to deal with diagram and what it all means. So.